binary search. Binary search is one of the core algorithms in computer science. Basically, you have to know it. You just have to. It's super easy, but it's like the basic of the most basic algorithm you can learn. It's super fast because it has a type of complexity of O log n, which is like super fast. And in the best case scenario, we can have O of 1 when the target value is in the middle of the array. And the space complexity is also negligible because it's just O of 1. Okay, so first of all, we will start with the lead code problem. So we need to find a target number in some array of numbers. And the easiest way we could do it is just iterate over every element of this array and just return the index if we find it. But this approach it's of course super simple, but it's also will take a lot of time. If, for example, we have like thousands of elements in this array, so the type complexity is O of n. So we need to operate on every number in this array. Of course, this will work, but it takes some time. It even needs to speed up, right? So it's not a good approach. I have here example array on which I will explain to you the binary search. So first what we need to do to implement the binary search is to create two pointers, left and right, or maybe a different color. And also we need to then calculate a midpoint. How we do it? It's super simple. Basically, our midpoint is the L plus R divided by 2. So in this case, our L is on index 0 and R is on index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So yeah, I had to calculate it. So maybe for simplicity, I will also type indexes here. Okay. So we don't have to calculate it every time. So basically our midpoint now is 0 plus 10 divided by 2. So it's 5. Now our midpoint is at 5. But what I forget to do is to tell you what is the target we are searching for. So our target in this case, for example, could be 56. Okay, so our target is 56 and our midpoint is now on the index of 5. Okay, it's so our midpoint is not equal to the target. Target is more than 23. So what we need to do now is because midpoint it's 23 and this is not equal to 56, it's less than 56. Okay, so we need to change the position of the left pointer, because when the target is more than the midpoint, we upgrade the left pointer, and in the opposite scenario, we downgrade the right pointer. I will show you this example in a moment, but first of all, let's find our target. So this means that we need to add to our left pointer. So our left pointer equals midpoint plus 1. So this will be 5 plus 1, so 6. So now our left pointer goes here. So now left is here. Right pointer stays in the same position. So now we have to calculate the new position of the midpoint. Okay, so m equals, again, 6 plus 10 equals 16, divided by 2, it's 8. Okay, and the value of the array at index 8 is 56, which is our target. Okay, that means we are gonna return the index of this target. Okay, return, and it's 8. So we found our first target. Now I will show you what happens if the target is in the first part of the array. So first of all, so for example, we can select 8 as our target. Okay, and our new target will be 8. I will delete all of that. We don't need it anymore. Okay. Okay, R is in the same position. Okay. And once again, we have to get our midpoint. We remember it was 5, so I want to calculate it again. So let's just put our midpoint here. And we see that the value of array in the index of m is more than our target. So let's write it down. Okay, so m is 23. 23 is more than our target. That means that our r now equals m minus 1. Okay? And that means that r is equal to 4. So we move our r to 4. Okay? And calculate the new midpoint. Okay, so new m equals 0 plus 4. So 4 divided by 2 equals just 2. And our midpoint is on the target. So let's write it down. Equals 8 equals target. And that means we return the index of 8. So it's 2. Of course, this is just a simple example. I hope that you understand how it works by now. And what happens if our target is not in the array? So for example, instead of 8, I will search for 30. 30 is not in our array. Okay, let's delete all of that. Also, we won't calculate again the first midpoint, so we'll just leave it here. Okay, and our value of the array at midpoint is 23. Okay, and 23 is less than our target, so that means that L equals M plus 1. Okay, and now, so that means that it equals 6. We'll move it to 6. Okay. And again, we check our new midpoint. So midpoint equals 16 divided by 2. So 8. Our new midpoint is at 8. And 8 is more than our target. So what happens now? I'll write it down again. So m equals 56. 56 is more than the target. So our right pointer equals m minus 1. M minus 1 is 7. Okay. And yeah, we need to swap it. So r is now here. And we need to calculate our new midpoint. Okay, so m equals 6 plus 7, so 13. 13 divided by 2. That will be 6, I think it because in most of the languages the integers are rounded down, so it will be 6. So our midpoint is now on the position of the left pointer. Okay, and it's still too much. It's 38. 38 is more than our target. That means that r equals m minus 1. And that means it's equal to 6. So now our pointers are on the same position. And basically, if we now go one more iteration, so m equals, I will write it down again. So we are in the same position, equals 6 plus 6 divided by 2. Yes. So it will be just 6. And our value at the index is, of course, 38. 38 is still more than the target. So r equals m minus 1. That equals 5. And now our right pointer is less than the left pointer. So that means that the target is not existent in the array. And that means that we will return minus 1. It's by convention, if we can't find index of something, we return minus 1. So because left is more than r, that means we return minus 1. So I hope with these 3 examples, you now understand how in theory it works. So let's now implement the correct solution. So what we are going to do is we will, first of all, go with the left pointer. So left pointer will be equal to 0. Right pointer will be equal to nums.len minus 1. So we are at the last index, okay? And while left is less or equal to right, we will calculate the m. Okay, so m equals, of course, left plus right divided by 2. Okay, and if nums on the midpoint equals target, we return the m. Okay, but what happens if, for example, nums are higher than target? We remember that we calculate the new version of r, of course, and then continue. Okay, and also what happens when nums are smaller than the target? Left equals, as we remember, m plus 1. Okay, continue. Okay, and of course, if we don't find it, we return minus 1. Let's now run it, check if everything is correct. Of course, yeah, my bad. Happens to the best of us, right? Okay, and if we submit it, it also should work. And it's accepted. Runtime beats 100% because it's the fastest solution for this problem. But there is one more thing we can improve here. In some languages like Java, when the n is big, like humongously big, we can have one problem, and that is the integer overflow. So if we add 2 super big integers, we can get outside of the bounds of the integers. So what we can improve here, and if you are on, for example, some job interview, you might be asked about it. So what we can improve here, instead of calculating this way, we can do it like this. So we go L plus R minus L divided by 2. This way, we calculate the distance and we avoid the integer overflow. Of course, in languages like, for example, Python, that might not be a problem, but in Java, it will be. So let's submit it again. Okay, and we also get the same solution. If you want to learn more about Java ecosystem and Spring Boot and everything that is connected to the backend development, check out the top link in the description for my private community. Here is the next video, YouTube things you should watch, and till next time, create some amazing applications.